Hi, this is Anthony Garland, and I'll be giving a short presentation about Graderworks and how it can help you as a SOLIDWORKS educator. Graderworks is a product from Garland Industries, and we are a certified solution partner with SOLIDWORKS. So, like I said, my name is Anthony, and I teach SOLIDWORKS at Clemson University, and also I'm a software developer. And at Garland Industries, we basically do software development for mechanical engineering applications, some additive manufacturing software, and also Graderworks. Basically try to automate tasks which are difficult or impossible for engineers to do manually. So some more background, like I said, I teach at Clemson University, and students learn how to generate 3D models in the class, in the SOLIDWORKS class. And it's a very large class. All the mechanical engineering, industrial engineering, bioengineering, and material science majors are required to take the class, and the result is that it's a very large class. Clemson is a big university. So each year, combining both semesters, the spring and fall semesters, combined, we'll have about 700 students take the class. And really our goal for the class is for the students to have a minimum skill level within SOLIDWORKS, and we assess that. One of the ways we assess that is we want the students to pass the SOLIDWORKS Associates exam, and we make them take that for during the class. So we have this question, which is, how do students get better at 3D modeling? And the answer with almost any type of skill that you're learning is pretty much always the same. You need to practice. So the problem is, with the SOLIDWORKS class, is we have this dilemma as an educator, and that the students need to get better by practice. So I want to assign a large amount of homework, but if I do assign a lot of homework, then I have to grade it. And how am I going to do that? And grading SOLIDWORKS models turns out to be especially difficult for a variety of reasons. One is the 3D models are large. Most educators, including myself, I'm not running a high-performance computer. I'm just running my laptop. Second, 3D models are difficult. It's difficult to find errors because they're very complex. Like, they have many different sketches, many different features, and it can be hard and very time-consuming to go through and check every little detail. Third is, like we talked about before, we learn by practice. Students learn by practice, so there's going to be a lot of homework. So at Clemson, we assign about 2 quizzes each week in addition to a homework assignment that's due at the end of the week. So like this next semester, there'll be about 500 students taking the class, 2 quizzes in the week. That'll be 1,000 files. The homework assignment might require the students to make like 3 or 4 models. So we have, let's say, 4 models times 500 students. That'll be 2,000 models plus the quizzes. So up to 3,000 models in 1 week. That's a lot of grading. Finally, because all the models are supposed to look the same, if they're following like a tutorial from the textbook or doing an assignment at the end of the chapter in the textbook, all the models should look exactly the same. So you can't just look at it and decide if a student has shared a file. Like, we need something a little bit more robust than that. So the solution is Graderworks. And what does it do exactly? First, it reads students' parts, assemblies, or drawings. Then it will extract the mass properties and some metadata. It can also compare the students' geometry of their model with the correct answer's geometry. It can export the feature tree data. You can capture a screenshot of every file and save that as a picture file. It checks for plagiarism as well. So here's a general example of how you would use Graderworks. First, you assign homework. This could be from the textbook, like I said, following a tutorial or something at the end of a chapter. Or we oftentimes assign, for these quizzes that we give the students a PDF with an engineering drawing on them, and we ask them to reproduce the 3D model within SOLIDWORKS. Later on in the class, we will also ask them to actually make an engineering drawing, but when they first start, we're just trying to get them able to actually make a 3D model in SOLIDWORKS. So we'll give them PDF. They need to make the 3D model and then turn it in to a course management system. That could be like Blackboard, Canvas, Schoology, Moodle, or whatever your school is using. Next, we'll download the results of all of the students and put them into a single folder. Next, I'm going to configure Graderworks. I have to tell it where on my computer all the files are located. What type of file is it? Is this like a part, assembly, or drawing? Also, I can tell it if the student's work is in like a zip folder containing several parts, or is it in a folder, like each student has submitted a folder with parts in it. So there's a lot of different options. And finally, I'm going to also tell it what is the correct answer or answers for this particular assignment. Next, I'm going to run Graderworks. It's going to loop over the files, analyzing them, extracting data, and checking for plagiarism. I can monitor the progress. As it goes along, it's going to tell me how much longer it thinks it has, which student's file or files it's working on. Depending on how fast your computer is, this could take a long time. Also depending on how big the files are, and there's a lot of variables that go into it. Finally, I'm going to view the results. There's two results I'm going to check. First, I'm going to check for plagiarism. I'll talk more about that in a minute. The second check is, or second thing I'm going to look at with the results is taking the output and converting that into a grade. So you can see in this Excel spreadsheet on the left, I have the student's username, file name, I have their mass, volume, density. I have the comparison, the geometric comparison to the correct answer. And finally, I just set up some simple Excel formulas to compute a grade in the far right column, column T. We'll talk more about this in a minute too. So the first big objective is checking for plagiarism. How can I know that my students did their own work? And unfortunately, in an education setting, it's not a matter of if students are going to plagiarize. Students will try to plagiarize, and it's more of how we can handle the situation when it happens. In this sense, Graderworks is similar to Turnitin. It's just a simple plagiarism checker. So at Clemson University, SOLIDWORKS is generally taken by sophomores. And I tell you that to you so that you understand their maturity level. So they're not just freshmen, but most of them are sophomores. Anyway, I tell the students that we have a plagiarism checking software, and still about 2 to 3% of students will turn in a plagiarized file. And unfortunately, that makes a lot of work for the student and also for us to have to go through the procedure when we catch someone. So Graderworks checks for plagiarism in several different ways, and it will flag these files, and it's up to the instructor to make a judgment or get more information about whether or not it actually is plagiarism, but this gives you a good starting point. So the first one is an inconsistent save by name. So let's say a student turns in 4 files for an assignment. 3 of them, the last saved by name is Bob, and the last one, the last saved by name is John. That doesn't necessarily mean they plagiarized, but it might be something we want to look into. Like, for example, maybe their computer stopped working and they used their friend's computer for the last part. So maybe that's why the last saved by name was different. There's just something we might want to look into. A duplicate saved by name for different students. So let's say Bob turns in 4 files and the last saved by name is John. John turns in 4 files and the last saved by name is also John. Again, that does not necessarily mean they plagiarized files, but it's something I might want to look into. Like, it could have just borrowed a computer. This third check is generally the best, and it's the duplicate creation date for different students. So let's say John turns in some files, and last saved by name is John. Bob turns in some files, and last saved by name is Bob. However, the students were made at exactly the same time. SOLIDWORKS records the creation date down to the second. So on December 2nd at 6 p.m. and 6 p.m. and 58 seconds, they both made the same part at the same time. If the parts look basically the same and the creation date is exactly the same to the second, that is highly suspicious, and I definitely want to take a closer look at that. That is, with a very large class, it's actually possible, I see this at Clemson, that like 2 students can make the same file at the same time, but it's not normally the same type of part. Like one might be doing the first file for assignment, another student might be making like the last file. But basically, we should be very suspicious and want to look and get some more information. The final one is a check on the creation date. Like, is the creation date reasonable? And this is helpful because if a student gets a file from a previous semester or maybe from the internet, then the creation date will be unusually old. And Graderworks is just to try to detect that. It's just going to find the average creation date and basically find anything that's outside of the normal range. It's going to flag as something I might want to look into. So I've been saying I want to get more information. How exactly do I do that? So what am I going to do now if I suspect plagiarism? So what we do is we use Graderworks to extract the feature tree information of the specific files that we're interested in. From the feature tree, for every feature used within the file, I can extract what type of feature it is, the name of the feature, the creation date of the feature, the last modified date, and the last saved by username. And this is the ultimate check because 2 students cannot make the same features at the same time on the same computer. So by looking at that creation date for the features, that is the absolute check. So even if one student's computer is not working, you can't borrow someone else's computer while he's still working on it. Like the creation dates would be different for the features, unless of course it's plagiarized. So that's the plagiarism check. That's the first major use of Graderworks. The second is actually grading. So the output of Graderworks is the 2 files. One is the output.csv, the other one's the analysis.csv. The analysis.csv file is the plagiarism check, whereas the output.csv file contains attributes about all the files that Graderworks analyzed. So it's going to tell me like the mass, volume, surface area, center of mass, and the x, y, and z density. Also the geometric similarity to the correct answer, or if I said there was multiple correct answers, then a comparison to each one of the correct answers. So what we can do then is to set up a simple algorithm in Excel to check for the to grade the students' files. So for example, I want to check that they assigned the correct material, and I can do that by looking at the density. Like if the density of the let's say the correct answer is supposed to be made out of titanium, then I can just check the density of their part, the student's part, and if it has the same density, then they assign the material to titanium. If it's something different, then they didn't do it right. Also, I can grade for whether or not they got the shape right, whether or not the geometry is correct. And there's 2 ways we generally do this. One is we check the mass or volume, and this is exactly the same as what SOLIDWORKS does on the CSWA when they ask you to report the volume of a part that you've modeled. So we do that. However, it's possible that a student could find out the correct mass from his friend and then just like draw the box and extrude it a certain amount and then get the correct mass. So we also do the geometric similarity test to see if it's going to see if the shape is correct. Now the interesting thing is that the similarity comparison score is quite accurate, and that like if there's even a single sketch that is not fully defined, normally that will throw off the geometry enough that the the geometric similarity score will be lower, and to say that it's not exactly the same. It'll say it's like 98% similar, but it's not within the tolerance that's given by the output. So if it's not 100% correct, then we can assign partial credit automatically based on how similar it is. So if someone just draws a cube and turns that in, that should be assigned much lower score than someone that just made a tiny mistake. You know, like they forgot one dimension on one of their sketches, and then that threw off their mass and also the actual geometry. Like maybe the sketch looked right, but it just wasn't fully defined. We can do something similar for rigid assemblies, where we can independently grade the two aspects of the assembly. So in this, on this slide, the top right is a practice question from the assembly section of the CSWA, where you're given the parts and you're asked to put it together. So there's two things that should be checked. One is the assembly put together correctly? And second is, are the parts placed within the assembly correctly with respect to the origin of the assembly? So in this picture, the assembly origin is in the bottom left, and then the mass will be, and the center mass will be influenced on that. However, let's say a student doesn't get the origin correct, but he's put together the rest of the assembly correctly. We can actually check that. So the geometry will be correct if the assembly is put together correctly, but the center of mass will not be correct. So one way we can grade these is I can do like 10 points for the correct material, potentially. And then for each center of mass component in the X, Y, and Z, I can do like 16 points. And then 40 points for having mated everything together correctly. Again, that'll be checked by the geometric similarity score. And that can all be automated within Excel. So thanks for watching, and if you have any questions, please contact us through our website on the contact form. And also there's a lot more information on the website about Graderworks, and if you teach SOLIDWORKS, you can get a free semester-long trial of using Graderworks. And also, if you don't teach Graderworks, you just want to play around with it, it comes with a 30-day free trial built into it automatically. So thank you again for watching, and contact us if you have any questions.